Welcome to the Graphing Display Calculator tutorial video. In this video, we'll practice some calculator functions that we want to use. Also, it'll specifically focus on the topics of function. Before we start, if there are any issues with your calculator, something's wrong, something's not working, then it might be a good idea to just reset it. So if you press second, plus go to memory, press 7, go to reset, all RAM, reset, and then it'll be cleared. Okay, so let's start from the main menu. Okay, one thing we need to remember is that the negative and minus are different. Negative is written as this negative sign here, and minus is the minus here. Okay, they look different. If you want to write -1, let's say you try to do -1, you can see that it doesn't work. It doesn't let you do that, right? And it's not going to go anywhere. So make sure you put negative here, 1. That will give us -1. Okay. And also you here see this the answer here. So what that means is that it is going to use a previous answer as an input. So here, if I put answer -1, it's going to go -1 minus 1, so it's going to give you -2. You can manually use the second answer here, to use it. Okay, so for example, if I want to do 1 minus answer, then I can do 1 divided by second answer, -0.5. Lastly, on this section, we're going to use the STO button. This means store, and it stores an answer or a number to an alphabet. This works with the alpha button here. So let's try to save our answer as A. Okay, so second answer, store alpha A. Okay, so what it does is I can use A as a variable, which is I can use alpha A squared plus alpha A. Let's see what that gives us. -0.25. Okay. So let's try another number. If you don't want to use the answer, you can just store, like for example 5, and store it on B. Yeah. So I can try like alpha A plus alpha B. One thing to be careful when you're using the calculator is the brackets. Calculators are not so good with the order of operations, or when we put in the expression, they tend to mess up at some point. Good rule of thumb is to quote as many things as possible within the brackets, and make sure you keep count of how many brackets that you want to use. You should close all the brackets, or else the calculator will shout at you. Okay. Power button. So some other things. Power button here works the same as our keyboard, and the squared and other buttons work like they should. Okay. Notice that some features are in the second mode. For example, if you want to do square root of pi, you can do second square root second pi. Okay. So pay attention to these features. If you're looking for other mathematical operations, they may be hidden in the math button. Let's see what's there. So under math tab, there are some operations we can use, such as cube root, root with other indexes, and the one that I like the most is the first one, the frac. Okay, the fraction. This changes the decimal number to fractions. Okay, so let's try what it looks like. So let's try if you put 0.575757575757, and then let's see. Okay, if I change that to fraction. Okay, so I write that math frac, and then I see it's 19 over 33. So again, remember math frac, enter. On the math function, let's look at numbers. Some other parts here too. You could try the abs. The abs stands for absolute function or absolute value. So if you press that, let's say I put like -5, it's going to give me positive 5. Okay, let's move on to the graphing part. So graphing part, we get through the y equals. Okay. This is the main window that you'll find yourself a lot in functions. Let's type in any function and graph it. Something like x. Let's graph. Yay. Now let's go back to y equals. There are some things we need to know. First, we can scroll to the left, and we can hide or display the function. See how the equal sign is coded in black? If I press enter, I can uncode it, and you can see now it's not coded. And then if I press graph again, the graph is invisible. Okay, let's go back again. Let's press left one more time. Okay, and then we can change the shape of the line or the function. Okay, we can make it thicker, and now it got thicker. So let's turn it on again, and then the line's thicker, and so on. Okay, there are some other features as well. The one with the graphing above it, okay, probably used for inequalities. You can graph below it, and this is like, you know, a cursor follows it. This one's cursor follows it but does not leave a trail. I don't know what they're useful for. The most useful, I think, it's the dotted line here. Okay, maybe you can't see it so much here. Let's try something like x squared. You can see that's a dotted line here. Okay. One more thing. Let's put another function and see what happens. Let's put x here. Let's change back the shape into the original, and then graph it. Aha! Now there are 2 points, 2 functions. And there's a way we do the first function minus the second function. So let's go back to y equals. Let's go to the third function, and then we're going to press vars, go to y vars, press function, and then we can select which one we want to use. We can go 1. And then, so now what it does, it takes the first function as an input. And then let's try something like y1 minus. Let's do the same thing one more time for y2, vars, y vars, function 2, y2. Aha. And then what it does is I sketch the third function. And here it looks kind of, you know, complicated here. So let's hide the first 2 because we don't need to see it. And then we only see the last function. Right. Now let's go to window. If you press window, so this window allows the size of the window we're seeing. Okay, so let's change it a bit. Perhaps we could try x-min as -5, x-max as +5. Let's try that y-min as -2, and the y-max as something like 20. Okay, so this looks a bit more promising than the last one. This is useful when we want to graph something extremely bigger, such as something like -x squared minus, let's clean everything from last, something like -x squared minus 150x. Okay, so if you graph it, okay, so that doesn't really tell us anything, right? So in the normal window setting, we won't see the graph, so we have to manually change the window. So now let's go to window. Let's change the x-min to -160 and x-max to something like 10. Let's put y-min to 0 and y-max to something like 6,000. That looks a lot better, isn't it? Okay. By the way, so how did I come up with these values? Perhaps you need to do some algebra work here. I know by factorizations, the x-intercepts of this function are 0 and 150, so that's why -150. So that's why I included those in the window setting. And also by looking at the vertex of the function, I know the highest point is somewhere just below 6,000. So just below 6,000. So that's why I put my y-max at 6,000. Okay. If you want to go back to the original view, let's press zoom, and we can press zoom standard. So this is something that you will use a lot, zoom 6. And then we go back to the regular, negative 10 to 10 and negative 10 to 10 on both axes. Okay. If you want to just zoom in or zoom out, you can use those functions too, such as zoom in to zoom in. So now we zoomed in here. Okay, you can use the zoom out as well. Okay. If you're dealing with trig functions, you may find the z trig quite useful. Z trig. Okay, so what it does, it changes the window from negative 2 pi to positive 2 pi, and then my x scale into half pi. Also, my y min goes from negative 4 to y max equals 4. So let's try something like y equals sine x. Let's try again, sine x. I can see that it follows very nicely. Okay, from the negative 2 pi to positive 2 pi. Okay. Next, let's look at the trace. Okay, so if you press trace, what it does, it creates a cursor on the function, and as I move my arrow key, I can see that my arrow key follows the function. Okay, so if I don't do that, if I don't have the trace, then my cursor is just floating, off the function, which might not be so useful. So that's why we use a trace if you want to trace the function. Okay. The fun part is just above the trace. It's the calculate part. This is one of the key parts of this video. So let's look at second calculate. Okay, so we're going to use a lot of this throughout. Let's first start with the value. Okay, so what the value does is I can press a specific value of x, right? So if I press x equals 0 and enter, that tells me where the x is, or where the y-intercept is. Okay, so if you're wondering, if you graph something and you're wondering what the y-intercept is, you go second calculate, value, and then 0. Okay, and if you want to try some other numbers, such as value, let's try something like second pi minus 6, just for fun. Okay, so I know that, okay, my y value is 0.5. Okay. Right, let's move on. Second calculate again, and then let's look at the 0. Okay, so what the 0 does is it finds the zeros as a function, or x-intercepts. Okay, and we see the question. Okay, so let's press 2, and then now it asks you, okay, what is the left bound? So what it does, because there are multiple x-intercepts here, it's asking for which x-intercept to look for. Okay, let's try the next one here. So it's asking for the left bound, so I want to put my cursor on the left-hand side of my x-intercept that we're looking at. Okay, so I'm going to put here, enter, and then let's scroll more, and now it's asking for the right bound. Stop about here, enter, and then we're going to guess, and the calculator tells me that the x-intercept happens at 3.14, which is pi, and y value is, so sometimes that happens on calculator. It's going to produce something like 1 times 10 to the power of negative 13, and which is basically 0. We know that. Okay. Right. So if you want, you can try to repeat this process on your own to find other x-intercepts. Okay. And by the way, at this point, you can press clear and go to the main menu and see how the x was that. So what I can do, let's go to the main menu, let's go to x and then see what it does. Oh, see the value that we just found, or the 0 that we just found, had x equals 3.14. So now I can use x as 3.14. Okay. Alright, so let's move on. Let's go back to the graph, and let's just use second calculate again and look for a minimum and maximum. Okay. So what did they do is, now I'm looking for the minimum value. So let's do the same. We can do the same thing, the left bound, the right bound thing, and it looks for the minimum value within that range. Okay. So the minimum value between these ranges are obviously 4.71 blah blah blah, and y value is -1. Okay, so I think that's something like 5 pi over 2? No. 3 pi over 2. 3 pi. No, what? 3 pi over 2. Yeah, 3 pi over 2. Right, okay. So now, okay, the next one is the intersect. So what I'm going to do, I'm going to put another function. Let's say something like, x squared. And then let's see what it does. Aha, okay, so I see. Let's zoom in just a bit because we want to see closer. Okay, see what it does. It zooms in. See, okay. So, if I use the intersect button, now we can look for the point of intersection. Okay, so how I do that? Let's press second, calculate, intersect. Okay, so this one you don't have to really move around unless you want to look for another intersect points. Okay, that looks about right. So we can press enter, 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 and okay, so we know that they intersect 0, 0. Okay, that's kind of boring. Let's try to find another point of intersection. Second, calculate. Again, 5. Let's scroll through so it goes close to the point of intersection here. Okay, so enter, enter, enter. Aha, so I know that our two functions intersect at 0.877 and 0.769. Okay, remember that point of intersection is useful when you're looking for the x value when f of x equals g of x. Okay, so when you see the question like two functions are equal, if you want to solve it graphically, you can put them into the graphing calculator and then look for the point of intersections. Okay, right, last one. Okay, we can go to table by putting the second table, and what it does, we can see the table of values for integer values of x. Okay, perhaps you will find them useful. If you want to change the increment here, okay, you can press plus here, or if you want, you can go to second table set, and here what it does, you can switch the starting position, and also you can switch the increment. Let's put something like pi divided by 4. Okay, graph that. No, okay, actually, my bad. I shouldn't graph that. Sorry. Perhaps your calculator is faster than mine. Right, second table. Aha, so now my left hand side, the x values are increasing every pi over 4. You can see the fifth one is pi. And then my y values are going to, go from 0, square root 2, over 2, 1, things like that. Yeah. Okay? Right. Okay, so that's it for the video. If you want more help with other topics of math and their calculator usage, please write a comment below and I'll make a video on that part as well. Alright? Best wishes.